here are doing a great job of keeping up to date with your work in Ingenuity. So good job to you guys. I would say that about 50% of the class is where they need to be. So good job to you. You are supposed to be going through the simplifying radicals. So the first part of this unit was on Pythagorean theorem, solving for a missing side. They broke it up into a few sections of Pythagorean theorem. And then the remainder of it is all dealing with like square roots. So simplifying square roots, simplifying radicals, and then there's adding and subtracting, multiplying and dividing. So there's like a whole bunch of sections. And then the last one is graphing. So I was going to go over questions that you have at this point and then kind of do like a little overview of those, like dividing with radicals and adding and subtracting. And then the last section is graphing, I believe. So I was going to show you just a preview of that so that when you get to that section, hopefully you have a little bit better understanding for however they present it to you. Okay. But ideally, you should be finishing up that unit test by Monday would be the ideal time to kind of give you enough time for the rest of the material to finish throughout the semester. If you finish earlier, fantastic. But by early next week, you should try to be done with that unit test is the goal, so that you have enough time to keep working through the other stuff. Okay. So before I get started, are there specific questions that you guys got stuck on, like a topic or things that you didn't understand in the videos that or the material that you learned? So I'll open that up first. Go ahead and put in the chat if you did have a question. I would like to answer your guys' questions first before I kind of jump in and do a little preview of the other stuff. So feel free to write in the chat. It doesn't have to be a specific problem, just a section that you had a hard time on, and I can find problems to put up. So any questions? I would say most of you guys who are in here are doing a good job on your scores as well. So are you guys doing okay with that material so far? Okay. Well, I don't see any questions. So I'll go ahead and hop on real quick with simplifying radical expressions. Sorry, I was looking at something and it's not what I thought. Okay. Okay. So how are you guys doing with just the simplifying radicals with variables and things under the square root? Like something like the square root of 63t to the third power. Are we able to simplify those? Are these problems like something like this that you can do? You're doing good with that? Okay, great. So this, I'll just do it since I have it up here. This would be 9 times 7. You would do a t squared and a t, like that. And then you can take the square root of 9. You can take the square root of the t squared. So square root of 9 is 3. Square root of t squared is t. And there's a leftover 7t in the square root. Okay, so we're feeling kind of okay with those. Have you guys seen the phrase rationalize the denominator? Have they said that specific phrase to you? Okay, so let me go just do a problem on rationalizing the denominator. The short story for that is that you can't leave a square root in the denominator of a fraction. That's basically all it means. So if you had something like square root of 3 over square root of 7, so you have this, can't simplify, but I have a square root in the denominator. You have to get rid of it. So the way to get rid of this is whatever is in that denominator, I'm going to multiply by square root of 7 over square root of 7. Okay, so square root of 7 over square root of 7 is 1. So I'm not technically changing the problem. That's why this works. But when I multiply this on the bottom, square root of 7 times square root of 7, square root of 49, which now I'll be able to take that square root. So I end up with square root of 49, which becomes a 7. Then on the top, I'm just going to multiply these. Square root of 3 times square root of 7 would be square root of 21. And I can't simplify that. That just stays like that. So it'll be square root of 21 over 7. Okay, so that's like a very simple way to do rationalizing the denominator. A lot of times you'll simplify a problem and then at the end you don't simplify out all of the square root in the denominator. And so this is the process that you would go through. Just trying to look for another one. Did you guys have more? Do you want me to do more examples of this, rationalizing the denominator? Because I can pick some like harder problems too, if you would like some more examples with rationalizing the denominator. Go ahead and type in the chat, like, nope, I'm good with it, or yes, please do more examples. Anybody? And I'm happy to do more. I just don't want to. Okay, yes, I can do a few more examples. I just don't want to waste your time. If you think it's super easy, we can move on to something else. But yeah, I'm happy to do examples. Let me just pull some other problems that I can find. I think most of the ones we show you guys tend to be pretty simple or simpler. They're not super complex. I'm not sure what they're showing you, but we can look. So here's another one. So here I have 6 over square root of 2. So I can't simplify that because the 2 is under a square root. It's like locked in there. You can't do that. So, but I still have to get rid of that square root. So again, same strategy. I'm going to multiply by square root of 2 over square root of 2. So I'm going to do that. On the top, the 6 does not have a square root. So when you multiply that, it's going to be 6 square root of 2. It doesn't multiply under the square root. Okay, that 2 is still under there. And so it looks like that. On the bottom here, I'd get square root of 2 times square root of 2, which is square root of 4. And the whole point of this is going to simplify. If you're good at this, you can just do this step in your head. You don't have to write this twice, but I'm just showing you guys. So you end up with 6 square root of 2 over 2. However, on this one, you can simplify this. Can you guys tell what you're going to simplify? I can't touch that square root of 2. That's like locked in that square root. But the 6 over 2 here, I can simplify. So 2 goes into 6 3 times, and so I'll get 3 square root of 2. So I would say, like in a normal class situation, when I would give quizzes and tests, a lot of students would get to here, but then lose like minor points for not simplifying all the way. So if you're doing like a multiple choice on the ingenuity, they might have this as like an answer, but really you want to simplify it one more step. So because this isn't wrong, it's just not done. So make sure you're simplifying as much as possible, like to get to that. Okay. Let me erase this. Room. Oh, welcome, Dakota. Glad you could join us. Okay, let me see if I could do another one. I'm sure I have 1,000 examples of this. Okay, so I'll just do one more of that. So square root of 2 over, actually, let me look at the worksheet really quick. Okay, sorry, I was just looking at the worksheet that I normally assign, but so this is typical of the type of problem that you would have to do with simplifying the denominator. So this one again, square root of 2 over square root of 5, and then multiply by square root of 5 over square root of 5. On top, these both have square roots, so I can multiply those together. So this will be square root of 10. On the bottom, I'll have square root of 5 times square root of 5, which is square root of 25, which will simplify to 5. Again, the goal is the denominator. You don't want to simplify 5s at this point. You could simplify, cross off of 5, and you'd end up back with square root of 2 or square root of 5. So the goal of this is to get rid of this square root in the denominator. Okay? So that's your final answer, which these ones seem to be tricky. You cannot cancel that 5 with the square root of 10. That square root of 10 is locked in that square root, and so you can't simplify that. So this would be your final answer. Okay, so hopefully that helps with those simplifying with the denominator, the square roots, rationalizing denominator. One of the next sections that you guys do on here, or normally would do in class too, is when you start adding and subtracting radicals. Okay, so I'm gonna erase this one. Let me see, I forget the order. Do you guys do multiplying first? I think you do multiplying. Sorry, I think you do multiplying first. Let me do an example of that. So multiplying with, well, they kind of all go together. So we'll start with adding and subtracting, sorry. So let me do a little example. So if you have 6 square root of 11, the big difference here is the problems that I've shown you so far, these were all multiplying. So now we're switching to this, which is a plus, okay? And then 9 square root of 11. The square roots you want to treat basically just like they're variables, like as if this was like 6x plus 9x. You can only combine them if they're exactly the same. Like if this was 6x plus 9y, you guys know you can't put that together. So you want to treat those square roots just like you would a variable, okay? So this, you're going to add the 6 and the 9 and have it be square root of 11. So it should be 15 square root of 11. Just like this would be 6x plus 9x, you would have 15x. Okay, it works exactly the same. As long as they're the same square root, you can do that. Okay, and then that's it. You can't simplify that. That would be it. You'd be done there. And it works the same for subtraction, but a lot of times they don't give them to you like in the most simplified form. You might have something like 5 square root of 3 minus square root of 12. This would be like a typical problem that you would most likely see for addition and subtraction. So if you notice, the 3 and the 12 don't match, but I can simplify that square root of 12. So the square root of 12, you know, it's 4 times 3. Okay, so I'm going to take the square root of 4, and so this will be 2 square root of 3. Are we okay with that step? I hope I'm not going too fast, but just simplifying that square root of 12 to 2 square root of 3. And then now you notice these match exactly. So I can subtract 5 minus 2, and I'll have 3 square root of 3. Okay, so if they don't match to begin with, your first step is to simplify that square root. So is this about kind of like where most of you guys are in working on those? How do you guys feel about problems like this? Feeling pretty good? Oh, good. Awesome. Okay. So there's those type of problems where you simplify the square root and then combine them, whether it's addition or subtraction. You can also see multiplying with this stuff. So multiplying, you would have something like square root of 10 and then square root of 6 is 3. So a problem like this, where you're going to FOIL, okay, you have to, but it's just using square roots. So square root of 10. So if they both have square roots, this is multiplication. You can multiply them. So here, when I do square root of 10 times square root of 6, that will be square root of 60. Then I also have to FOIL, so square root of 10 times the 3. The 3 does not have a square root, so it stays 3 square root of 10. Okay, so you can only multiply those ones that have a square root. And then, of course, you have to simplify this. So this will be 4 and 15, I guess. So since this is 4 times 15, I take the square root of 4, so it'll be 2 square root of 15 plus 3 square root of 10. Okay, so I just simplified that right there. But these square roots don't match. They're not the same, so I can't combine them. I just leave it like that. That's your final answer. Okay, so again, like these would be like different variables. Okay, so like 2x plus 3y. That's it. You can't combine that anymore. You're done. Okay. So that's the adding and subtracting. Most of the operations. You guys also probably had to do some foiling. Did you guys have to FOIL with the square roots? Have you guys seen those problems? Where they might give you something like, it's hard because the problems that I typically give you, I'm not necessarily sure those are the problems that they give you on Ingenuity. So something like this, 7 plus 3 square root of 5, 7 minus 3 square root of 5. Have you guys seen those? Where you FOIL these? So you use the same FOIL technique where you do first, outside, inside, last. So we're just, 7 times 7 would be 49. Then my outside one would be 7 and negative 3. So negative 21 square root of 5. Inside term would be plus 21 square root of 5. And then my last term is going to be minus, the 3 times 3 is 9. And then the square root, I have 5 times 5, which would be square root of 25, which I'll simplify. So the way this one's set up, the 21 square root of 5 plus 21 square root of 5, those are gone. Okay, so I end up with 49 minus 9, and then the square root of 25 I can simplify, which is a 5. So that's times 5. So 49 minus 45. This all turns out to be 4 in this case. Okay, so have you seen that? It's the same technique as you just FOIL and just be real careful with what you're multiplying. If the number's on the outside, it multiplies the number outside. If the number's a square root, it multiplies to the square root. And so be real careful with those things. Okay. In this unit that they're doing, have you guys done any solving equations with radicals? I couldn't tell from the titles. I didn't think you had, but I'm not sure if there are also solving equations in there, the square roots. Have you guys seen solving radical equations? I know there's graphing, so I'm going to cover the graphing, but I wasn't sure if you guys have done the solving. Can you guys let me know? Are there solving equations? Like something like, I'll just write an example. where it looks something like this. X, square root of x plus 7 equals 16. So this would be like the difference here is you're not just simplifying, you have an equal sign where you actually have to solve it. So have you guys seen problems like that? So let me know yes or no. Yeah, okay. Thank you. Thank you guys. I wasn't, from the titles, I couldn't tell that those problems were in there. So that might be in the next unit. They might put those in there. So I won't talk about that right now. But the last thing I do want to talk about is giving you a little preview of this graphing square root, so that they are going to have you graph those, which seems weird that they didn't do equations first, but that's okay. Okay, so I'll just do a quick little overview. You guys are going to learn this, but so when you're graphing like a square root function, so just y equals square root of x, you can write a table. But am I going to be able to put any negative number in here? Like, can I put -1? Can I take the square root of -1? No, I can't. Okay, well, it's not a real number. So what's the smallest number I can put in here for x that will work? The smallest one is going to be 0. So that's where I'm going to start my table, 0. So then I can take the square root of 0, and that's 0. Okay, so I want to be smart about the numbers that I pick here, because you want to be able to do this without a calculator. So I would pick 1 as well. Square root of 1 is 1. I'm going to skip 2, because if I plug in 2, I've got the square root of 2 as a decimal. It doesn't really help me if I'm going to graph this. Same with 3. I'm going to skip that. I can't take the square root of 3. And jump down to 4. Okay, because then I can take the square root of 4 is going to be 2. Okay, and just for graphing sake, what would be the next number that I'd want to put on there? What's the next perfect square that I can take? It would be 9. So square root of 9 is 3. Okay, so when you graph this, you're not going to have anything negative. Okay, so just do a little graph. So the x is going to go out longer than it's going to go up. And I'm just going to plot these. So 0, 0, and then 1, 1, 2, sorry, 4, 2, 1, 2, 4, 2, and then 9, 3. So it looks like that. And then you're just going to connect them. So it's going to look like this and keep going. And it's a curve. And if you notice, I can do it on this, it's like half a parabola. If I turned it this way, do you see that it looks just like a parabola? And then you would have it go like this way. Okay, but the negatives don't work. So it's a parabola just on its side. So it should be curved. It's not a straight line. They're all going to have curves. Okay. And so that's kind of like your general form of what the square root graph is going to look like. The only thing that happens is they get moved around or kind of stretched out, but they should pretty much always follow this general form. And then here, we're just going to talk about domain and range really quick, because that might come up. Normally, I talk about that too. So domain would be your x's. We said we can't plug in negatives. Our domain starts at 0 and can go to positive infinity. So how I write that is x is greater than or equal to 0. Okay. And then the range, we also saw we don't get any negative y's. It starts at 0 and it can go up to infinity there. So here my y's would be y is greater than or equal to 0. Okay, so a quick little domain and range. So basically they're just going to move this around. So I'll do like a couple little examples real quick for you. Move this little graph here. I can retap this. Okay, so if we had like square root of x plus 2, there we go. So sometimes there could be something in the square root with the x, or it could be outside. They can put numbers wherever we want. So I'm going to draw a table again. And I'm actually, because the square root of x is by itself, I'm going to use those same numbers. So I would use 0, 1, 4, 9. Those are the perfect squares. So those are the first ones I'm going to use. So if I plug in, I'd have 0, root of 0 plus 2 is 2. And then I'll have square root of 1 plus 2. So that's 1 plus 2 is 3. I have square root of 4 plus 2. Square root of 4 is 2, plus 2 is going to be 4. And then square root of 9 plus 2 would be 3, plus 2 is 5. Okay, so I just plugged it in just like we did before, but just adding 2 at the end. And then you're going to graph this. So instead of starting at 0, 0, we're starting at 0, 2. And I'm going to be at 1, 3. And then 4, 4. And 9, 5. Okay, so I plotted those points. And then again, it keeps the same shape. Okay, it just goes up like that. So here with that plus 2, it shifted the whole graph up 2 units. Okay, so that's what would happen with that. Again, let's just talk about the domain and range here again real quick. My domain, again, I did the same x's, so that's the same. X is greater than or equal to 0. But the range, the y's, what's the smallest y I can have here now? It wasn't starting at 0, 0. It's now up at 2. The smallest one I'm going to have is 2. So this will be y is greater than or equal to 2. And so that range changed there. And so if you saw a graph that was like y equals square root of x with the 3 on the outside and a minus 3, and we guessed what would happen to this. This one we did was plus 2. If I did minus 3, can we tell what would happen? This graph got shifted up 2. If I did a minus 3, the graph would just get shifted down 3. Okay, so having a number out here just shifts it up and down. How you shift it left to right is having a number in the square root. So if I had something like y equals square root of x plus 1 in here, this will shift it left and right. I don't want to do too many examples for you, but hopefully that gives you at least a preview of what the graphing the square root functions look like. Okay, so you guys can get to that section hopefully fairly easily now. So for those of you who hopped on while I was working, thank you guys for hopping on. The goal would be to finish this unit, which is the simplifying radicals and the Pythagorean theorem by Monday. If you can finish it earlier, awesome. But like by Monday, Tuesday, you should have that unit test done. So just so that you can keep up with the pacing. Most of you guys who are all on here are doing fine with that. So just keep that in mind. Okay, so are there any questions for me that I didn't cover or something that I did wasn't clear and you want another example? Let me know. We're about going to wrap it up, but unless there's any other questions I can answer specifically. I would be happy to do something else if you had another question. Anything else that you guys need? Good. I'm glad you guys are doing good. So I will hop on again a week from now, so next Tuesday, to kind of go over any last minute questions. If you guys haven't taken that unit test and you want like some other questions answered from the end of the chapter, feel free to hop on here Tuesday and then finish that test Tuesday afternoon. afternoon after we talk about some things. But again, the goal would be to finish that test like Monday, Tuesday next week. Okay. All right, you guys, thanks for tuning in. I will talk with you guys soon.